Hello, everyone. Welcome to the Siemens Digital Industry Software Energy Podcast. My name is Brendan Conley, and today we have a great lineup of guests to discuss the resurgence of nuclear energy in the digital age. To begin, I'll hand it off to Dr. Emilio Baglietto from MIT.
Thank you very much, Brendan. Well, the way I would introduce myself is, first of all, I'm a passionate nuclear engineer. I'm the associate department head in the Nuclear Science and Engineering Department at MIT, the Massachusetts Institute of Technology. Maybe I add one extra thing. I decided to become a nuclear engineer in 1988, 2 years after the Chernobyl accident, and I joined MIT in 2011, right after the Fukushima accident. So my passion is clearly not driven by fashion, right? So I'm a strong believer in the usefulness of nuclear energy.
All right. Thank you, Emilio. Next up, we have Greg Elliott.
Awesome. Thanks so much, Brendan, and happy to be on the podcast today. My name is Greg Elliott. I'm a solutions consultant with Siemens, based in Toronto, Canada. Super passionate about nuclear. My background, I've been in transmission and distribution for about 20 years. But in terms of specialization, my background is primarily data science, AI, machine learning. And, we're seeing a ton of, machine learning use cases pop out in nuclear today that I'm happy to share some insights there.
Thank you, Greg. And now I'll pass it to Matt McCullum.
Good afternoon. Thank you. Matt McCullum, and I'm an enterprise account executive with Siemens. I've been with the organization for about 14 years and have worked in a variety of different verticals and industries. But for the past 4 years, I've been spending my time in energy and utilities in central and eastern Canada. And as of late, the last couple of years, a very strong focus on nuclear and working directly alongside of Canada's nuclear organizations and helping them discover how Siemens can deliver value against their goals and objectives.
Excellent. And finally, our very own John Nixon.
Thanks, Brendan. I'm John Nixon, 30 plus years on the road since I left Texas A&M with a civil engineering degree, not nuclear, Dr. Baglietto, but have worked with the United Nations in Romania. I've worked on oil wells in China and pipelines and above ground storage tanks in southern Mexico, and worked in Canada, in my last tour, if you will, in energy on an open pit mine up by Crow Lake. So just a tremendous opportunity in life to work in every aspect of energy, chemicals, and infrastructure. Now I work here at Siemens, where I'm responsible for our global strategy in energy, chemicals, and infrastructure. And Brendan, our topic today about advanced nuclear, I couldn't be more excited about what's going on in the market around advanced nuclear when we're talking fission or fusion. So looking forward to having a great discussion about this today.
Thank you, John. So let's dive right in. Advanced nuclear has such a great buzz right now. What are some of the current trends, challenges, and opportunities that you see in the nuclear space?
I'll jump in here first on that. I don't think there's a morning we don't wake up to headlines around sustainability, decarbonization, how our species is experiencing a very momentous energy transition right now. And so at Siemens and with all of us here on this call, I know that this is a passion for all of us here to look at what are we going to leave the next generation and the generations after that with this planet. It's a tremendous opportunity to make that change. And when I look at advanced nuclear, you look at fission and fusion, and Dr. Baglietto, you'll probably talk about this. When you look at volumetric or gravimetric energy density, nothing compares to nuclear energy. It is unbelievable to take the embers of the Big Bang in fission and to release that energy. Or in the world of fusion, to be able to bring the power of the sun to the surface of the earth. It's an absolute incredible opportunity to truly put your head down at night when you go to sleep and say, I spent another day driving to fundamentally change the future for our children. Dr. Baglietto, your thoughts?
Absolutely. So as you mentioned, the power, right? What we can extract out of a nuclear reaction is an order of magnitude that is not comparable with anything else. We tell our students typically that the rough idea is that out of a pellet of uranium, I can produce the same energy that I would produce with 400,000 tons of coal. That's the kind of energy that we can generate. So why is nuclear finally coming up to be recognized as a fundamental contributor to clean energy, but in particular to energy security? Is that we are finally realizing that the energy consumption is not going to go down, right? it's only going to go in one direction. We will need more energy. And every nation that wants to remain competitive will need to double the amount of electricity we are producing, the amount of power. When you look at that, we don't have any other way to ensure grid stability, to ensure price stability. The history has already shown that, while we have done a lot of things wrong as nuclear industry in particular in recent times, we have shown that when we construct plants, is one of the only power where the price will only go down, will never increase the price of electricity. So when you build nuclear power plants, from the day you start operating, they will operate better. The cost of the fuel will go down. And that's a trend that we've guaranteed. Now, the challenge we've had is that, these big mega projects that we were trying to construct were very challenging. The technology that we were using is certainly old. This technology we started operating in the 60s. And we had a whole new family of reactor that are these advanced new reactors that are extremely exciting that we have never built. They have great promise, but we need to make this extra step of bringing it to the grid, learning how to operate them. But the potential they have is fantastic for the simplicity that they can operate, for the size that they can offer, the flexibility. And so that's why there is so much excitement, right? The first of these new concepts that will be able to succeed is going to change the way we see nuclear, right?
As you're talking about that, I was just recalling Greg said he has a data scientist background or data science background. I don't know, Dr. Baglietto, if people would have predicted even 5, let alone 10 years ago, the growth of data centers and the demand and the hunger for power. I think I read a headline the other day, Greg, where it said 9% of all U.S. energy consumption will be data centers by, I think, like 2030 or 2035. It's an incredible amount of growth. I'm sure you've been following that as well.
Yeah, I mean, no, I think it's a good area to pivot to when we think about nuclear facilities from a design perspective, and the future demand for capacity, and obviously that capacity has to come from, as Emilio was talking about, clean energy. We need to think about, okay, well, the advent of AI, the pressures that AI is putting on the marketplace, right? And obviously the demand of electricity that AI is putting on society itself, or Bitcoin, or whatever the case may be. Well, there's now a demand to build data centers and the required infrastructure to facilitate AI, to enable AI, to enable these digital technologies. And, to speak about, why nuclear companies are thinking about accelerating their designs is to meet that future capacity that's going to hit the grid, right? And so when we think about the math behind that, well, it takes about 18 to 24 months to design and construct a data center. But, traditionally, how long does it take to design and construct a nuclear facility? It's anywhere from 7 to 10 years on average. So that's another trend that we're seeing in the marketplace, which is nuclear designers and manufacturers, EPCs, thinking about how do we accelerate the design to meet this capacity into the future as a function of AI and other digital drivers.
So, John, you'll find this funny. Timing is always key. I'm not always good with timing, right? And so you'll find that in 2016, together with a colleague, Dr. Ian MacDonald, who is an architect in London who specializes in data center, we started a data center nuclear center in 2016. So when you say who could have predicted, we knew that was the direction. Now, we were not very good at convincing people back then. That I have to say. But definitely we knew, and I'll show you, we had some very interesting design concept. The big difference is that in 2016, what I envisioned, to be a few megawatt plant was the biggest size that I could imagine. I didn't have the AI requirements that we have today. Now, when I updated the plan of what that request would be, about a month ago, I had about 700 megawatts as the biggest site that I had seen requesting power. The week after, it got to 5 gigawatts. And last week, somebody proposed the 15 gigawatt. Now, that means 10 of the biggest nuclear reactors out there just to power up this center. So the numbers are escalating at an incredible pace.
Well, when I hear that, one of the examples that I use when I think about on-site nuclear, apart from data centers, and that just takes my breath away what you were talking about, I look at things like in 2021, during the winter of February of 2021, the entire state of Texas, where I'm here in Houston, Texas, was out of power for 90% of the state for a good month. And it took and I tell you what, when you live in a world that's fully digitalized like our lives are, and you have no power, and your neighbors don't, grocery stores don't, your libraries don't, and nobody has power, you are just losing your mind to live your life and to pay your bills and to move forward. And so we quickly saw in January of 23, Dow Corporation had a headline where they were going to install nuclear behind the meter in their Seadrift facility here in Texas. And I think in just the last 12 to 16 weeks, I've talked to almost as many customers or potential, companies we at Siemens would be speaking to in the advanced nuclear space, where they can't meet this growing demand for their power as fast as it's needed. And so there's just an aggressive, and I mean this in a positive way, there's a very aggressive pace to bring innovation into nuclear so that we don't have these extreme weather events or extreme events of any sort that then compromise this very electrified life that we live in. Now, that's in Texas. Matt, you're there in Canada. So you're living and breathing this on the front lines for us at Siemens. Matt, what are you seeing as challenges or opportunities there in nuclear? And quite frankly, one of the world's epicenters when it comes to nuclear. I mean, you've got France, you've got the U.S., but you've got to count Canada, if not number one, certainly in those top three epicenters for development around nuclear power.
Absolutely. And it's interesting what's taking place is we talk about a nuclear renaissance, which is very true, but there's also a renaissance in digital transformation and digitalization within the nuclear industry as well. We haven't had new reactors for many, many, many years in Canada. So the organizations are looking at this as not only an opportunity to build something new and build something fantastic to meet unparalleled demand in energy, which is not going to stop anytime soon, but it's an opportunity to do something different. It's an opportunity to look at how are we designing this? How are we managing the life cycle of the project? How are we collaborating with our supply chain, the entire value chain for that matter? So it's a really exciting time to be able to work with everybody and work with these owners as well as the equipment manufacturers and the EPCs that are all part of this, and bring technology to them that they're able to leverage to do things more efficiently and ensure that they're meeting safety requirements. They're making sure that deadlines are met on time. There's limited amount of rework and redesign that's needed, or not needed rather, that you would have seen 10, 20, 25 years ago. So a lot of exciting stuff happening.
Okay, well, thank you, gentlemen, for an excellent discussion, and thank you to all of our listeners out there. Stay tuned for part 2 in this nuclear series, where we'll explore topics like digital twins and predictive maintenance. Hello, everyone. Welcome to the Siemens Digital Industry Software Energy Podcast. My name is Brennan Conley, and today we're excited to bring you episode 2 in our nuclear series. John Nixon picks up right where we left off and jumps into supply chain and digitalization behind this energy transition.
So, Matt, as you're talking about, you mentioned the word supply chain, and what comes to my mind, and Greg or Amelia, you might want to jump in on this, but I think about how the last thing you want to see in the world of nuclear is anything associated with failure. Amelia, you mentioned Fukushima and Chernobyl. We've had 3 Mile Island. And when people hear the word nuclear, I think the layman or laywoman, out there thinks of, something quite catastrophic in their mind. So if we're going to embrace and have another nuclear renaissance or revolution occur, we can't afford to have any sort of like nuclear project delayed, nuclear project on hold. These kind of negative headlines are the last thing we need. So when I think supply chain, I start to think, as you were just indicating, Matt and Greg, in your comments, as we have this energy transition and this nuclear innovation that's going on, you also have digitalization, which has got to be behind that. We've got to make sure that things are on time, on budget, they're done safely, right? They're done with environmental stewardship at front of mind. You've got to do it right the first time. If you look at, let's say, the rest of energy as a proxy for performance, we have a very bad record as a species when it comes to large capital projects being on time and being on budget. And so I'm excited, though, that when I hear the challenge of data centers and the kind of electricity they're going to demand, what that also tells me, though, is there's a lot of computational power that's going to support this digitalization of our species that's needed to be able to have what we commonly, all of us on the call here refer to as a life cycle approach to data management going forward. So, Matt, as you're talking about these challenges and these opportunities in Canada specifically, of course, I see this globally, and I think we all do. We've got to have what I would say is a good foundation, to use a metaphor here, a good foundation to that digital home is well-orchestrated ontologies, is what I like to say, right? A strong taxonomy, a life cycle approach from design to scale up of that design into fabrication, into the receipt and assembly in the field. And then you've got the whole commissioning and startup process. And then, of course, the long-term operations and maintenance. And that carries a heavy load for data management. Greg, it looks like you're chomping at the bit to say something on that.
No, John, you're speaking to the choir here. So, I mean, let's be fair. Nuclear operations are quite resilient. They're reliable. They're already decarbonized. They're safe, right, at the end of the day. But that does not mean that, nuclear operations, especially what I'm seeing in Canada, are not trying to ramp up what you're talking about and specifically from an operations and maintenance standpoint, right? They're looking at the life cycle approach. From a predictive maintenance standpoint, we're seeing them look at digital twins to optimize the performance of their systems to better predict failure in critical assets and components. I mean, there's a number of different use cases. I mean, Matt and I can probably share just at a high level that, one of the nuclear operators that we're talking to today, I mean, at the end of the day, they've had a multiple month outage as a function of a stator failure in a generator. And they traced that back to, actually a problem related to maintenance. And it turned out that, 5 stators or 6 stators within, various different generators caused a significant downtime to operations. I mean, there's other examples, other use cases where catastrophic failure that, today, again, a lot of these nuclear owner operators just cannot predict. One example is predicting failure in an electrical motor in a primary heat transport system as a function of, stress corrosion cracking. So as Matt was talking about just briefly earlier on, a lot of these nuclear owner operators are thinking about, okay, well, how do we elevate our predictive maintenance programs to use, let's future-proof these outcomes with, let's say, multi-physics informed digital twins or other types of new age technology that we're seeing hit the market. And it's obviously part of some of the conversations we're having with our customers today.
There's new reactors that's being built, and that's what we're just talking about now. But then there's also the existing plants. And it's how do we make our existing plants more efficient? How do we look at how the assets are operating? How do we look at doing a better job of condition health monitoring? And there's a tremendous opportunity there as well. Again, safety, making sure that the plant is optimized, and how do we squeeze more power out of an existing facility just by operating it a little bit more efficiently? All things that, of course, can be accomplished through digital technologies. But one thing I'll mention too is that when the Monarch announcement was made, it was stated very clearly that they're designing the Monarch in Canada with maintenance in mind. So looking ahead to serviceability of the reactor, designing with maintenance in mind now eliminates so many of those challenges that we've seen over the last couple of decades with the older, existing designs, which is a giant leap forward. And that should help, I think, get more nuclear power in the backyards of, throughout the world. There's a political element to getting a new reactor in a country always. And there's a NIMBY effect as well that we see without question. So being able to, improve designs with maintenance in mind, ensuring safety is going to go a tremendous long way. So really great to see that, the new designs that are coming out today are taking all this into consideration.
Yeah, I've seen a tremendous in my interactions with customers directly. You look at fuel technology and the technologies around that have made it far safer. I would go so far as to say almost intrinsically safe, where if you did take humans out of the loop, you wouldn't find yourself facing the same challenges you would have back in the 70s and the 80s with your more conventional nuclear. So it's tremendous, the amount of innovation. And then, of course, with all of this computational power we're bringing online with these data centers, all of this AI, all of this physics-informed simulation and design, as you were talking about, Greg, it really does change the game as to what is possible now in advanced nuclear technologies.
So, Greg, I wanted to bring up a point you made regarding public perception of nuclear. At times in the past, there's been mixed or negative views on nuclear based on safety. What can you tell us about safety today and how the nuclear technology has progressed over the years?
So, no, absolutely, Brendan. And I think, at the end of the day, like if we look at historically, nuclear operations have been, resilient, reliable, quite safe and secure. But that's not to say that owner operators specifically aren't looking at ways to improve reliability, improve resiliency, safety. And of course, they're always looking at new ways to become more decarbonized, right? And so that being said, when I'm talking to owner operators specifically, what's the roadmap looking like for them in terms of creating this long-term vision of how do we create more resilient, reliable, safe, decarbonized? And also, one thing I left out was regulatorily compliant operations. Well, they're really thinking about, John touched on this topic earlier, they're thinking about, how do we consolidate data? How do we contextualize that information? Where I'm going with this is, how do we actually create a digital twin of our facility, right? And the power of that, really, at the end of the day, when you think about that, especially if you're embedding, AI, machine learning, multi-physics intelligence, or physics-informed models of that essentially mimic reality, right? And this can all be done today. This isn't 20 years out. So nuclear owner operators are thinking about this. And so what can they do with that type of digital twin? Well, if I take an example, let's say you're dealing with a, primary heat transport system, right? What does that look like? Well, you've got steam generators, you've got thermohydraulic systems, you've got, valving systems, actuators, you've got pump assemblies, you've got deuterium flowing through these complex piping systems. You've got let's say a calandria assembly. The bottom line is you've got all of these complex assets, systems, and processes working together to, essentially help the nuclear facility operate. But what you can do with the digital twin now is you can actually start to simulate different what if scenarios. So, for example, what if I change a pressure condition? What if I change a flow rate? What if I change an operating limit with a steam generator or a pump assembly? What are the types of upstream and downstream systemic risk can I glean from making these changes within a digital environment? I can also get more informed predictions of failure, right? And we're seeing this with a lot of owner operators today. They're unable to predict complex physics-based or environmental outputs that are driven by physics, like stress corrosion cracking, embrittlement, thermohydraulic instabilities, right? But you can do all that more accurately with AI, ML, and physics-informed intelligence. And so that's why owner operators are really thinking about digital twins today.
Yeah, I think that's an excellent observation. You think about the fidelity and the capabilities that we have virtually now over the physical world. And Greg, as you're talking, I again think back to this fidelity in the life cycle, if you will, if that's a way to say it, which is that as I look at the history of these fatigue mechanisms that you had mentioned earlier, and you start to ask why, and you want to be able to trace back so you can understand, is this a local challenge or is this a systemic challenge that I'm dealing with? Is it acute? Is it long term? These are the kind of questions you'll need rapid answers to, especially in advanced nuclear, when it comes to ongoing reliability, safety, and sustainability in this space. But there's decades of lessons learned and history from, again, by proxy, the rest of energy that we can glean from it, that those of us on this podcast, have worked many, many years, and in my case, many decades, bringing into this space to make sure that we learn from it, right? And that we grow from it. So yes, there's challenges, but gosh, the opportunities, as you just mentioned, Emilio, that we've now got because of the fidelity that's capable in what our CEO Roland Bush calls the industrial metaverse, right? He really puts his arms around all of it and talks about this industrial metaverse that's now available, for us here in Advanced Nuclear. Greg, any final thoughts?
No, I just wanted to kind of piggyback off of what Emilio just talked about. We're talking about fidelity of the models thanks to physics-informed intelligence, but I think one of the other things that we want to think about is speed, right? So speed to decisioning, speed to insights, leveraging these multi-physics powered digital twins, right? Because when we think about simulation in the traditional sense, it's been traditionally a design function, and all of us probably know on the call today that multi-physics simulations, whether they're 1D, 2D, 3D, of a complex system or asset would take, several days, several weeks to run a simulation to figure out, hey, where is the failure mode? Why is this thing failing? You guys talked about thermal fatigue as an example, right? But what we're doing and what we're seeing in the market is that now you can take this, what has traditionally been a design function, and now you can apply it in the context of operations and maintenance, right? Through what are called reduced order models, right? And so now we're seeing the market sort of investigate, what is a reduced order model? Why should I be using reduced order models and neural networks to start, running these simulations? And again, reduced order models or ROMs can enable the near real-time simulation of complex systems and assets. So that is a really, really cool innovation, I think.
Well, and when you talk about reduced order models and you think about, well, how many variables are there contributing to a function or a failure, as we had just discussed, and you find that there might be 20 variables that you've got that you're accounting for, but you find that 3 really are the biggest contributors, and the ability to kind of reduce the order of analysis to those 3 to be able to draw the conclusion quickly that you need is very powerful. So you're right. When you think about how AI allows us, and we do this every day at Siemens, to reduce the challenge here, the variability that you really can kind of focus in on what it's like, what is the few that contributes to the most, right? And be able to get after that. That becomes very powerful in this environment. So yeah, I'm glad you brought that up, Greg.
And the other cool thing about that, just to kind of, layer on top of what you just said, John, is the fact that you can take this concept or technology we call a reduced order model and have it sit on an HMI device or an edge device or an iPhone. And, an operator, maintainer, or an engineer can go in and actually simulate in near real time what's going on in the nuclear facility, right, to gain insights and make immediate decisions, right, and take action right away that are prescriptive and prognostic. So.
Well, I like that. That really does truly augment your augmented reality. We talk about that a lot. Oftentimes it's assisted reality, like in bygone days when I would go out to the field and I had a checklist, right, of what I needed to inspect or I needed to test. But to your point, I'm actually going out there and I'm getting a real understanding of what I'm actually looking at. And there's a reduced order model, a simulation that is present in front of me and in front of these devices.
Yeah, think of the ROM as just a virtual model of a real asset. So take a motor, for example. You can set up this reduced order model, run simulations to see, hey, when and how will this fail? So you can create degradation models, aging models, get insight into when this thing might fail as a function of environmental and physical processes. And how that actually helps the owner operators. They can do testing in advance of, maybe refurbishment activities or, overhauling activities. So, maybe I don't have to check on this thing every 6 years. I can, push it out to 9 years without actually having any impact on the overall operation from a downtime perspective, right?
Dr. Baglietto, any closing thoughts here as we near
this is an area where I've been working actively, spending a lot of time. We demonstrated just about a year ago one of these new reduced order model that is capable to predict in real time the accumulation of fatigue in one of the feed waters of a advanced SMR, right? So the operator would have now in the control room, as he's operating, the life, the aging of its pipe, understanding when the next maintenance is due. We presented this to the nuclear regulator, which is the last step also to approve the adoption of this kind of tools in operation. And the regulator is very excited as well, right? Of course, as a regulator, we have to do the extra step of demonstrating the accuracy of putting this type of systems on the field and see how they operate. But there is excitement on both sides of the operator and on the regulator. The more information you have about the plant, the happier you are. So that they're all extremely useful tools and capabilities.
So we're seeing the convergence of an energy transition powered by digitalization of, as somebody said earlier, renaissance. I think of it as a nuclear revolution that is, again, coupled together with very powerful, Greg, I think you would call design space exploration, if you will. So it just becomes this tremendous opportunity to, again, change the world that we're going to leave to the next generation and beyond. So Brendan, thanks for hosting us again for another podcast.
Thank you, John, and thank you to all of our listeners out there. Have a wonderful day, and we'll see you again on our next episode.